Friends, this is Dr. Lina Kawani, having 20 years teaching experience. I did MSc, BA, MPhil and PhD in mathematics. Today, I explain you the bisection method. Bisection method is slowly convergent method for finding a real root of the given equation. Today, we discuss the bisection method in numerical analysis. The bisection method is slowly convergent method. This method is the simplest method among all these methods like secant method, regular falsy method, Newton-Raphson's method and so on. Today, in this video, I discuss the geometrical representation of bisection method. Also, I solve the example of bisection method. Thank you. We would like to see geometrical representation of bisection method. First draw x-axis, then y-axis. Let y is equal to fx be a continuous curve. Select a point small a and small b such that f of a is positive and f of b is negative. Naturally, f of a point lies on the curve y is equal to fx. Similarly for f of b point. Clear? Here, let us give the name capital A be a point of AFA and capital B be a point of small b f of b. Now, f of A is positive, f of b is negative. If we join capital A and capital B point, it always intersect at x-axis and this intersection point is our root. In bisection method, our aim is to find this intersection point on x-axis. In this method, the first step is find A and B such that FA into FB less than 0. Second step, the first approximate root its formula is x1 is equal to a plus b divided by 2. Now here x1 that is a plus b divided by 2 that is it's bisect our interval. x1 is a plus b divided by 2. Originally our interval is small a to small b. Okay. Now, if we find the first approximate root that is a plus b divided by 2, it is the midpoint of the interval a to b. Now find f of x1. Third step, find f of x1. Now, in the figure, f of x1 is negative because it lies below the x-axis. The corresponding point is this x1 f of x1. We know that the standard theorem is if fa is positive and fb is negative and if we joint now from the figure it is clear that if we join the point capital A and capital B, the capital A is positive, capital B is negative. If we join A and B, then it always intersect x-axis and this intersection point is our root. Our aim is to find this intersection point by using bisection method. And in bisection method, how to find the first approximate root? Its formula is x1 is equal to a plus b divided by 2. How to choose a and b? The condition for choosing small a and small b is fa into fb less than 0. Okay? From the graph, f of a is positive. Why? Because it lies above the x-axis. F of b is negative because it lies below the x-axis. The third step is find f of x1. Here again there are possibilities. What can we say about f of x1? From the graph, it is clear that f of x1 is negative. Means here f of x1 is less than 0 because it lies below the x-axis. F of x1 is less than 0. Now f of x1 is negative. What should do? We know the standard theorem. If fa into fb less than 0, that means in the figure fa is positive, fb is negative. It always intersect at x-axis. Means here f of x1 is negative. Means choose a positive value such that product of these two numbers must be less than 0. F of x1 is less than 0. So previously f of a is positive. That means choose a and x1 such that fa into f of x1 is less than 0. The most important condition is the image of a is f of a, image of x1 is f of x1 and its product must be less than 0. Let us see in figure. Now our interval is a to x1. Clear? That is our second approximate root in fourth step. Second approximate root is x2 is equal to a plus x1 divided by 2.
That is, what is our interval? Our interval is a to x1. Clear? Therefore, x2 is equal to a plus x1 divided by 2. Originally, our interval is a to b. Now, after finding f of x1 and f of x1 is negative, therefore we choose f of a such that fa into f of x1 is less than 0. Therefore, our new interval is a to x1. Means originally our interval is a to b, close interval a to b. Then it's bisect our interval. Therefore, name of this method is bisection method. What is the next step? Continue same process, but up to how many steps? Means continue the same step up to we found the root up to desired accuracy. Means fifth step is find f of x2. Clear? Previously we have done find f of x1. That means here fifth step is find f of x2. Clear? Means then same process is repeated. Sixth step is whether f of x2 is less than 0 or greater than 0 or equal to 0. If f of x2 is equal to 0, then directly we can say that x2 is our root. If f of x2 is less than 0, then what happens? F of x2 is greater than 0, then what happens? Means same process we continue up to desired accuracy. Now we want to solve the example of the bisection method. Then this geometrically representation we can understand easily. Bisection method is slowly convergent method. But in this method, we will get the root definitely up to desired accuracy. We are going to solve the example of the bisection method. Find a root of the equation x cube minus x minus 11 equal to 0 up to fourth approximation. First, we define f of x. F of x equal to x cube minus x minus 11. Now, find f of 0. Here we want to find the positive root. Therefore, start from f of 0, then f1, f2, f3 and so on. That is, first put x is equal to 0 in the given equation, then x is equal to 1, then x is equal to 2 and so on. But how many steps? The first step is to find the value of small a and small b such that is to find a two consecutive value of small a and small b such that fa into fb less than 0. Now, first find f of 0. F of 0 is minus 11. F of 1. Substitute x is equal to 1 in the above equation. 1 cube is 1, minus 1, minus 11. 1 cancel, plus minus. Again the answer is minus 11. That it is negative. F0 is negative, F1 is negative. Therefore, continue the same process. The next value is 2. Let's put x is equal to 2 in the same equation. The f of 2 is 2 cube minus 2 minus 11. It is 8 minus 13, that is minus 5. Again it is negative, that is continue. The next value is x is equal to 3. x3, 3 cube means 27, minus 3 minus 11, that is minus 14, and it is 13. That means it is positive. F of 2 is negative, f of 3 is positive. The two consecutive value is 2 and 3 such that f2 into f3 is less than 0. Here we write the condition f2 into f3 is less than 0. Therefore, we stop here, and the reason root lies between 2 and 3 because f2 into f3 is less than 0. The first step, step number 1. What is our first approximate root? The first approximate root is let us use the notation x1. X1 is addition divided by 2. That is 2 plus 3 divided by 2. It is 2.5. Immediately find out f of x1. F of x1, that is 2.5 whole cube minus 2.5 minus 11. Why? Because fx is x cube minus x minus 11. So replace x by 2.5. Here it is little bit difficult to calculate ourselves. So use the calci. Always put our calci in radian. You can use the calci and its answer is 2.215. 2.215. I am using here calci. Now, f of 2.5, it is positive. So previously, where is negative number? The negative number is f of 2. Clear? So, f of 2 into f of 2.5 is less than 0. Because f of 2 is negative and f of 2 point is positive. What can we say? We say that root lies between 2 and 2.5, or we can write root lies in the interval 2 to 2.5. What is our second approximate root? Second approximate root is, our formula is addition divided by 2. Let us use the notation x2. The x2 is 2 plus 2.5 divided by 2. That is 4.5. And 4.5 divided by 2. It is 2.25. What should do? Immediately find out f of 2.25. f of 2.25 means 2.25 whole cube minus 2.25 minus 11. Use the calci and find the answer. Remember that. Put our calci in radian. Okay. Its answer, what it is? Its answer is minus 1.859375. It is negative. This is negative. What should do? Find the positive number. In previous step, the previously where is the positive? F of something is positive. We need. It is f of 2.5. F of 2.5, it is positive, and f of 2.25, it is negative. One is positive, another is negative. Its product is negative. That is, we can say that root lies between 2.25 and 2.5. Therefore, the third approximate root, let us use the notation x3. Its formula in bisection method is addition divided by 2. That is 2.25 plus 2.5 divided by 2. 2.25 plus 2.5 divided by 2. Its answer is 2.375 in calci. What should do? Immediately find out f of 2.37 by substituting this value in our original function, that is x cube minus x minus 11. Simplify by using the calci. Again, its value is 0.0214843. Point 0214843. Okay. Our aim is whether it is positive or negative. It is positive. So previously, what is the negative value? Because we need opposite sign. In each step, we have to select small a and small b such that fa into fb is less than 0. So here, f of 2.375, it is positive. So where is previously the negative number? So previously, the negative number is f of 2.5. Correct? That is f of 25. Root lies in the interval 2.25 to 2.375. Step number 4. approximate root. Fourth approximate root is x4 is equal to 2.25 plus 2.375 divided by 2. That is, our root is 2.3125. 2.3125 means the fourth approximate root is 2.3125. Thank you.
If you like this video, then like it, share it and subscribe it. If you have any comment or if you want to know some more topics in mathematics, then please comment us. Thank you.